Good day, everyone. Someone has asked me if I could go through an explanation of how we can determine the equation of a sine function if you know the coordinates of a minimum point on the function and then you know the coordinates of the maximum point that occurs immediately after that minimum point. The bottom line here is in order for you to determine the equation of the function, you need to understand that the function will be defined by these four parameters, a, b, c, and d. And we'll get into the nuts and bolts of what those parameters tell us about the graph of the function in a minute. But to begin with, I just want to remind everybody that a, b, c, and d are called parameters, and they are numbers. They are values that you put into this equation at the top of the screen, and depending on what those values are for a, b, c, and d, you get different graphs. You get different sine graphs. So the properties of the graph of the function are connected to those numbers. Let's start by plotting these points, 30 degrees, comma, negative 12. In my experience, trying to plot these onto a coordinate grid, in other words, drawing an x and a y set of axes, is more trouble than it's worth. I don't think it's that helpful. All you need to be able to do is plot the points in open space here. So this is a minimum value, or a minimum point, and it has coordinates of 30 degrees, comma, negative 12. And then a short time later, or a short distance later horizontally, what you have is you have a maximum, and the maximum has coordinates of 150 degrees, comma, positive 1. So since the x-coordinate of the maximum is 150, it is to the right of the minimum, whose x-coordinate is only 30, and the y-coordinate of the maximum is 1, which is clearly greater than the y-coordinate of the minimum. When I get students to solve these kinds of problems in my class, I always recommend that they draw horizontal lines in three particular locations. One of the locations will always be where the minimum is. One of the locations will always be where the maximum is. And then we need to draw as well we don't need to, but I recommend it, a horizontal line which is in between the maximum and the minimum and is halfway in between. And I'm going to write the equations of these lines, these horizontal lines. The equation of the top horizontal line is y is equal to 1. Every point on that line has a y value of 1. The equation of the line below it, on the very bottom of my diagram, will be y equals negative 12. And these two y values are very important in us deciding the following two parameter values. We can determine from the maximum y and the minimum y what the parameter a and the parameter d is. The first thing to note is that this distance from the middle to the top or from the middle to the bottom is what we refer to as the amplitude of the graph. It is capital A. And we are allowed to say that whatever the amplitude is, that is going to be the parameter lowercase a. I'm not going to go through an explanation of why the amplitude happens to be equal to the parameter a. I'll link to a video in the description here of a lesson where I go through all of the parameters a, b, c, and d in terms of the graphs. The bottom line is if we can determine that amplitude, we know a. The other thing that we've learned in previous lessons is that the y value of the middle line that I've drawn here is d. And there are a lot of different ways that we can use the maximum value of 1 and the minimum value of 12 to determine both the amplitude and d, which is called the vertical displacement. What I tend to do is I take the 1 minus the negative 12, and what I discover is that this distance from here to here is 13. And that means that half of that distance would be the amplitude. If I want to know how far it is from negative 12 to 1, I can take 1 and subtract negative 12 and get 13, which means that this is equal to 6.5, and this is equal to 6.5. So I know that I can use 6.5 for A. You might be wondering, can I use negative 6.5? I certainly can use negative 6.5, and all that would mean is that the graph would be vertically inverted relative to if it were positive 6.5. It doesn't really matter. If you want to use negative 6.5, you can. I'm going to stick with positive 6.5. By the way, what that tells you is when we get an equation, there are many different equations you're going to get which will be correct. So that's the value of A, 6.5. If we want to determine the value of D, you can take the minimum value of Y, which is negative 12, and add the 6.5 to take you up to D. If you want to determine the value of D, you could take the maximum value of 1 and subtract the amplitude of 6.5. So I can do this in my head, and you can as well, I'm sure, but what I'm going to do is use my calculator. I'm going to take negative 12, and I'm going to add the amplitude of 6.5, which takes me to the middle line, which would be what D is. D is negative 5.5. Just to check things out, if I take the maximum value of Y and subtract the amplitude, I still get negative 5.5. So far what we have is that A is equal to 6.5 and D is equal to negative 5.5. We still have B and C to go. C is always the last thing you should determine. C is the most difficult to determine, and of the different methods that I've seen for finding C, I think the best one needs you to find all of the other parameters first. So how are we going to find B? We are going to remember that the period of a sine or a cosine function is 360 degrees divided by the value of B, or the value of B is 360 degrees divided by the period. So K is the period. And the period is the horizontal domain over which the graph repeats. Now, if you take a look at what I've drawn so far, this graph would go up from this minimum. I'll use green so you can see it better. It would go up from this minimum to the middle, then it would change the direction in which it curves, and it would have that overall shape. But that's only 1/2 of a period. A period is a complete cycle of, in this case, up, up, and then down, down. So a complete period would continue down and continue down to here. This distance that I'm going to highlight in, yellow, this is the period. And when you look at the x-coordinate of the minimum, it's 30. This point has a horizontal location of 30. This point has a horizontal location of 150. So if I take 150 and subtract 30, then the distance between, I'm just calling it a distance, the distance horizontally between those 2 points is going to be 120. But the period is the distance between these 2 lines, which would be twice as great, which means the period is 240. And now what we can do, now that you've determined the period is 240 degrees, we can find B by taking 360 degrees divided by 240 degrees, and getting B has a value of 3/2. I'm pretty sure 360 over 240 reduces to 3/2. You can confirm that on your calculator. So now we know the value of B. And what I would tell my students in my Math 30 class is that finding A, finding D, and finding B is fairly straightforward. It doesn't require too much work. You do need to know the connection between the parameters and the period and the parameters. and the amplitude and the vertical displacement. You need to know all that. And once again, you can watch a video on that I will link in the description of this video. Now, how is it we find C? The answer is we load in these three parameters that we know into this equation. And then after we load it in, I'll tell you what we need to do. So this function will be y equals 6.5 multiplied by the sine of 3/2 times x minus c, which we don't know. We don't know what c is. We're getting there. Plus d, and d is negative 5.5. Now, all I've done is I've put in to that general formula, a is 6.5, b is 3/2, and d is negative 5.5. I've always tried to, in my classes, impress on people that when you have something like this, that c is referred to as a missing parameter. It's why whenever I hear somebody refer to this letter C as a variable, I cringe. It's not a variable. X and Y are variables. C is a parameter. We always find a missing parameter the same way all the time. You find the value of a missing parameter by putting an ordered pair in for X and Y in the equation that has the missing parameter. An ordered pair has to be the coordinates of a point that lie on the graph. Now, what I'm about to show you will only work if the coordinates you use are the coordinates of a minimum or a maximum. It will not work reliably. It might, by a fluke, work sometimes, but it will not work reliably unless you use the coordinates of the maximum or the coordinates of a minimum. So I'm going to go with the maximum. I'm going to use 150, 1. While I'm here, I'm also going to write 30, negative 12, because I think what I'd like to do is after we finish this question, instead of using the 150, 1, I'm going to use the 30, negative 12 and see what happens. So all I'm about to do here, everybody, is wherever there's an x in the equation, I'm going to put 150 degrees. And wherever there is a 1 in the equation, wherever there is a y in the equation, I'm going to put the number 1. X is 150, y is 1. So what happens? Just want to get rid of this. We don't need it anymore. What happens is I get y, which is 1, is equal to 6.5 multiplied by the sine of 3/2 times x, which is 150 minus c, minus 5.5. Now forget for a second here, don't worry too much about this, but just for the time being, forget about how to find c and just look at the equation in terms of what we have. You have mathematical operations and numbers and an unknown, which is c. You ought to be able to solve that. So how are we going to solve this for c? We're going to start by, and I wouldn't normally write all of these steps, but in this video I think I can. I would start by adding 5.5 to both sides and getting 6.5 equals 6.5 sine 3/2 150 degrees minus c. And then I'm going to divide both sides by 6.5. And I'm going to end up with the number 1 equals sine of 3/2 times 150 degrees minus c. Now, if you have done things right, this number here will always be a 1 or a negative 1. So now what do? We understand that this is saying sine of some angle equals 1. The angle is quite a complicated thing. By the way, that A that I've written there is not for amplitude, it's just an angle. This whole thing is some angle, so the sine of that angle is 1. And you should know that on the unit circle, sine is the y-coordinate on the unit circle. And the y-coordinate on the unit circle has a value of 1 here, which means that that angle is 90 degrees. That blue thing that I've highlighted is 90 degrees. So 90 degrees is equal to 3/2 times 150 degrees minus c, and we can solve that now for c. If I multiply both sides by 2, I get 180 degrees equals 3 times 150 degrees minus c. I can divide both sides by 3 and get 60 degrees equals 150 degrees minus c. If I add c to the other side and I subtract 60 from the other side, I end up with c is equal to 90 degrees. That's just a fluke that it's the same as that angle. Now what do we know? We know that the equation was y equals a sine b x minus c plus d, but now we know a, b, c, and d. A was 6.5, b is 3/2, c is 90 degrees, and d is negative 5.5. And that's the answer to the question. Just to convince you of that, I'm going to use my calculator. I'm going to graph that function. What do we have? 6.5 sine, and then I'm just going to put 1.5 instead of 3/2. Another set of brackets, x minus 90. Close all the brackets and subtract 5.5. Now I need to be really careful here. I want to double check things. Oh, 6.5. So 6.5 sine, 1.5 bracket x minus 90, n bracket minus 5.5. I need to make sure I'm in degree mode, because this question has all been about degrees, and I'm going to manually set up my window settings so that they will include these points. Let's go from 0 for x up to, let's go past 150, let's go up to maybe 360 degrees, up in lumps of 90 if you want to scale it so that it looks presentable. The minimum is negative 12, the maximum is 1, so I'm going to go from negative 15 to say 5. And I should be looking now at a nice sinusoidal function. And not only that, the minimum should be at 30 comma negative 12. If I go trace and enter an x-coordinate of 30, you can see that it has a y-coordinate of negative 12. If I go trace and enter an x-coordinate of 150, I get a y-coordinate of 1. So this equation that we've developed is correct. And everything that we did here, you would do the same way if it were a cosine function. However, just before I sign off, I want to point out to you what would happen if we would have done the exact same thing, but instead use this ordered pair rather than the 150 comma 1. If we use that ordered pair, then this number would have been negative 12. I might as well just erase everything below. And instead of having 150, we would have had 30. That would be the only difference. Instead of having 30 or 150 for x and 1 for y, we now have 30 for x and negative 12 for y. You would still add 5.5 to both sides. You would say plus 5.5, plus 5.5. But what you would get here would be negative 6.5 is equal to 6.5 times sine of 3/2 times 30 minus c. And when you divide both sides by the 6.5, you're going to end up with negative 1 equals the sine of this thing. And that means negative 1 is equal to the sine of some angle. Well, again, it's the y coordinate that's the sine. And that will be this point here. And here's where you have options, and you're going to get slightly different answers depending on the option you choose. We could certainly say that the angle is 270 degrees. And if you do, that means 270 degrees is 3/2 times 30 minus c. If I multiply 270 by 2 and then divide it by 3, what I end up with, I believe, is 180 degrees equals 30 minus c. And that means c is going to be negative 150 degrees. 30 minus 180. I'm not going to write out the equation, but everything else would be the same. So I'm going to now plot that new equation, 6.5 sine 3/2 bracket x minus negative 150 this time, close brackets, and then minus 5.5. And I'm going to just change the animation of this to demonstrate to you that you get the exact same graph, even though you have a different value of c. And in this case, it depends on whether you want to use an angle of 270, or you could have said, I'm going to say this is negative 90 degrees, and I'm going to set 3/2 times 30 minus c equal to negative 90, and you get a different value of c. Bottom line is there's multiple different answers you can get to this question. But going with the first method and choosing the point 150 degrees, comma 1, we end up with that equation for an answer. Anyway, I hope that's helpful. It's maybe one of the more complicated things you have to do in terms of trigonometric functions and graphs, finding that value of c. Once again, I hope that was helpful. Take care.